Hello everyone and welcome to another video on African Tech Gurus. On this video we're going to cover the tasks for function pointers, and previously we have looked at the content, we've had a review of it, and we have also looked at the quizzes and explained each and every single question and how to go about it. If you've not watched those videos, I will link the links to those videos above and you can watch them to make sure you've understood the concepts before we dive into the tasks today. So I've already opened my Git bash on my local machine and I already have the task open. So we'll quickly dive into it. So we are supposed to cover a few tasks. They are five. There are 5 tasks. So that's what you're supposed to be doing today. So the very first one is telling us to write a function that will print a name, and we already have the prototype of that function, and we already have the main file.c, which will contain the main function where the program will start. So before you actually start any task, there is usually the GitHub repository where it's supposed to be located. You should have it in your GitHub and you should clone it if you've not cloned it. But if you don't know how to do that, I believe we also have a video on that. I will link it above or in the description box for you to be able to follow through. The next thing is we need to have a directory. So that's where we should start, by creating the directory. So let me do that first. So mkdir and the name of the directory, which is 0f function and pointers. I always advise to always copy as it is so that you're able to get the correct output. And if we now list, we do have our file. Here it is. So now we can change our directory and move into that directory. So now if we are to print our working directory, we can see that we are already inside the directory that we have created. So we always need to create a readme file, and I'm just going to quickly do that. And I always just put in the name of the topic that you're supposed to be covering today, which is function pointers. So let me just paste in that. You can edit it as much as you want, but for the sake of time, I'll leave it at that, and then I will save it. So now when we list all our files, we already have the readme file. So if we are to look at this specific question, they've told us to write a function that prints a name, and they have already given us the prototype. So remember, each and every task has a prototype, and there is a prototype file that will contain all the prototypes. So let me just put that in, and I already had all of them, and they're supposed to be in a file called function_pointers.h. So here I have written all the prototypes of all the tasks that are required. So I'll quickly copy this before we move on to anything else. Create the file vi, I'll use vi, and copy the functions prototypes. They are that, and then now we can paste them here such that each and every single time we use the prototypes in our solutions, it will always have reference to this specific file. So now we can save that. Another thing that we always use a lot is the putchar, and I usually like just to create it on my side. So let me create that as well, and I will paste it here, and now we can have this. So copy it and paste it. For the putchar, it's always provided, so it's the very same thing. I've not changed anything. It's just that I usually like having it with my other files on my local PC such that everything is able to run correctly. So now if you're to list our files, we have our readme file which contains a description of what the project is all about and the entire scope of the different tasks that we'll be covering. You can put that in. I also have my putcar .c file, and I have my prototypes file, which is called functions underscore pointers. So now we can look at the first task, and we have 0.main file over here, so we need to create that on our local PC. So let me just create that right now, and this is the entire code that is here. It goes all the way to that point. So this is what will help us run GCC as well. And here it has a function which is called print name as is, and here it has it will take a name and it will get that name, and the other thing that it will do is it will change each and every single letter of that name to uppercase, and those are the two main things that are happening in the main file. So now we can save this, and now we can move to the solution. The solution is supposed to be in a file called 0print name. So let us create that over here. And we can now look at the solution and explain what is happening. I usually have all the solutions in one file so that it's easy even for me to revise later on. So here, this is what is happening, and what is happening here, this is an implementation of just a function called print name. That's the name of the function, and that is what is going to be implemented. So what is going to happen, it's going to take in two arguments. The first is this before the comma, that's the first argument, and the second is this, that's the second argument. So the first argument is a string called name, and the second is a pointer to a function f that takes a string as an argument and it returns nothing. So here, as you can notice, is you can have a function which is dependent on another function. So here it's also possible to do that, and what will happen is the purpose of this function is just to print the name using the function pointed to by f. That's all that's happening here. So it will first check if the name is null, which is the first argument that has been provided, or if f, which is the function, which is the second argument, is also null. And if either of this argument is null, then the function will return nothing immediately. But if both arguments are provided correctly and both are valid, then the function will call the function print name will call the function f. This is the function f, which is now being pointed to by f, and with the name as the parameter. So at the end of the day, the function, which is print name, calls the function pointed to by f, this, the function pointed to by f, with name as its argument, and the behavior of print name will be now dependent on this second function, as I have mentioned. So at the end of the day, this function will provide just a way for us to pass functions as an argument to another function, and this will definitely help in terms of having greater flexibility and also in terms of reuse of the different code that you have. So at the end of it all, here the function being pointed to by f will just be able to print the name that has been provided by the user, or what that was provided as is in the main file, as we have seen previously. So we can copy this and paste it here. Hopefully it will run. So we paste it here, paste it there, and save your file. The next thing that we should do is run GCC and hope that everything runs as expected. So let us now copy this GCC command so that we are able to compile the files that we have. Hopefully it runs successfully and it will give us an executable file. called A. So now we can execute it and it should give us hello, my name is Bob, and also change the name Bob Dylan to uppercase. So that is the same output as was provided here. So now we are good to go, and now we know that our solution is working perfectly. So the next question is, if you spend too much time thinking about it, about a thing, you'll never get it done. So here we're supposed to write a function that executes a function given as a parameter on each element of an array. So previously we've seen that you can pass a function within a function, but here they want us to make sure that we write a function that executes another function given as a parameter on each and every single element that is provided in an array. We already have the prototype, which we added in the functions pointer.h file, which I am highlighting right now. And here we can use size, which will point to the size of the array, and action, which is a pointer to the function that you need to use. So the very first thing that we can use over here is create this main file that we have been provided, such that we're able to compile everything that we have. And we copy it all the way up to that point and paste it there. Once we've pasted it there, now we can save it. And what is happening in this code? So the first thing that we have is we have a function here which takes in one argument of type integer, and it prints that specific element or the elements that have been provided. And then the other thing that we have is we have another function called print element hex, which prints an integer in hexadecimal format. And here we have an array of 5 elements, and these are the elements which are all integers, and they are passed into the function and they're printed individual elements and their hexadecimal values. So now we need to have our file, which is called one array iterator, and it will contain the solution, and we should get these outputs. These are the first elements, the 5 elements that are in the array, and they're all in decimal format, and they're hexadecimal formats as well. So this is the output that you expect to find once we have our solution. So let us look at the solution and then explain what is happening. So here we do have we've included the header file, which is our user-defined header file that contains all our prototypes. And the next thing that we do have is the prototype. And what is the prototype doing? So what is happening in this function is it will take in 3 arguments. As you can see, we have this is the first, this is the second, and this is the third. So you can quickly just have a look at it and you'll figure out how many arguments or parameters it is taking. And here it is taking 3 arguments. So there's an array of integers, which is this, which is the first one. The second one is the size of the array, and lastly is a pointer to a function which is called action that takes in an integer argument and returns nothing. I can repeat that. So this is a pointer to a function. A pointer to a function. How do we know that? This asterisk tells us it's a pointer. This is the name of the function, and this is the argument of the function, which is an integer, and it returns nothing because this is void. So what will this function do? The purpose of this function is to apply the function that is passed by the pointer pointed to by action, such that each element of the array is passed through this specific function. So first, the function will check that each and every element or argument passed in the array iterator function is not null. And if either argument is null, then the function will immediately return nothing. So if either of these 2, because those are the two that might not have something, because we've already initialized our array. So here, if any of these two contains a null is null, then the argument or the function will return nothing immediately. But if both arguments are valid and we do have the integers that are being passed into the function, then this function will enter this while loop. This one that I'm highlighting right now, it will enter this while loop that iterates or goes through the array from the very first element to the last, and inside the loop the function calls the function pointed to by action. So action is a function pointing to something, so it will the function will call that function that is pointed to by the pointer action with the current element of the array as its argument. So wherever it is in the specific array, whatever value it's at, its current element of the array, it will pass it to the function that is being pointed to by action. So at the end of the day, overall, this function will provide a way to apply a function to each and every single element in an array that you have created or has been passed into it in C, which is practically the language that we are using. And just like the previous example, it will allow for greater flexibility and also for us to be able to reuse code instead of rewriting each and every single piece of code over and over again. So now we can copy this and have it in our file. This is the name of the file, so we can create it. We paste it here. And the next thing that we do is copy the solution that we do have. And if I can mention, there are very many ways of doing the solutions, but this is just my way of doing it. You can have other ways of doing it, as long as at the end of the day you get the output that we have been provided for. So you can even decide to use a for loop. You don't necessarily need to use a while loop, just that you're able to iterate through the array that you have been provided for. So now we can escape and save this, and the next thing that we need to do is run GCC, and it will give us a executable file called B, and you can run B for it to be able to give us this output that we can see over here. So now we can execute, and as you can see, we do have the elements in decimal format and their hexadecimal values as well. So now we know we are good to go. So now we can move on to the next task. Let me clear this so that you're able to have a better view. So here we do have the third question, which is to hell with circumstances, I create opportunities. And what you're supposed to do here is you're supposed to write a function that searches for an integer. And we already do have the prototype that we've been provided for, and we've been told that size is the number of elements that are in the array, which is called array, and CMP is a pointer to the function that will be used to compare these two values. And lastly, and we do have int underscore index, which will return the index of the very first element, for which the CMP function does not return 0. And if no element matches, then it should return -1. And if the size is less than 0, then it should return -1 as well. So the very first thing that we will do is we will create this file that they have provided for us called 2-main. So let me write it here, 2-main, paste it, and have this. So what is this doing? So the first thing is we have a function called is underscore 98, and what it does is it will check if the number that is provided is equals to 98, and element or lm is the integer to check. So it will just check if 98 is equivalent to the specific element that has been passed, and then it will also check if a number is greater than 0, which is what we want, and 0 if false, and something else otherwise, that is what we will get as the return value for this. And we also have another function called abs is 98. And what does it do? It will check if the absolute value of a number is 98, and it will check this against lm, which is the integer that we're going to check against. And we also do have the array, which is the name of the array, and it has 20 elements, and these are the elements that have been passed into this array called array. So now we can copy this and paste it in to create our file called 2-main, which will help us create the solution and compile. So we paste it there, and now we can save it. Our solution should be in a file called 2-int_index. So we do vi and the name of the file that we want to create. And the next thing is, let's look at the solution and explain what is happening before we actually put it in. So here, as usual, we have our file that will contain all our prototypes, and the solution starts at this point. These are the comments just explaining what is happening. And here we do have an implementation of a function called int_index, and it takes in 3 arguments. The first is int, and the array, we have the size of that array, and we have another function. So it takes in 3 arguments. So these 3 arguments, the first is an array of integers. The second is the size of the array, and it is called size. Size will contain the size of the array. And lastly is a pointer to a function. The pointer to the function is this. CMP is the pointer to a function that takes in an integer argument, and this time it returns an integer as well. So those are the 3 arguments that will be passed into this function called int_index. So the first function, int_index, what it will do is it will search for an integer in an array of integers, and array, that is the array of integers. Size, as I've mentioned, is the size of the array, and CMP, this is a pointer to a function that will be used now to compare the values that we have. So it will take in 1 argument, which is a value, and compare it and return a value for us. So what will this function do? So this function will search for an integer in the array, and the array is created in the main file, and it will use the CMP function, that is one of its arguments, to compare the elements or the element of the array with the integer that you are searching for. So let me go through that again. So what will this function do? It will search for an integer. It will search for an integer in the array by using the CMP function, and it will compare the elements of the array with an integer that has been searched for or is being searched for. So it will check if both the array and the CMP function or arguments are null, and if they are null, then it will return -1, which is what we were told to do, indicating that the integer value was not found. But if both arguments are valid, then the function will enter the loop that will now iterate through the array. So this is what checks if the array and CMP values are null, and if they are null, it returns a -1 to show us that there is no integer that was found. But if everything is okay, it will move into the for loop. This is the for loop, and it will iterate through the array from the first element all the way to the very last. And inside this loop, what will happen the function will also call the CMP function with the current element of the array as its argument. And if the CMP function does not return a 0 for an element of the array, then the function will immediately return the index of that element. But if no element of the array satisfies the condition of the CMP function, then it should return a -1. So at the end of the day, this function will provide a way for us to search for an integer in an array of integers, and it will do so by using a custom comparison function in C. And this will now even give us greater flexibility and help us even to use the code as I have previously mentioned in the previous two tasks. So now we can implement this solution. So we create the file. We have created the file, so we just need to have it contain our solution. So there's our solution, and now we can save it. And after saving it, now we can run our GCC. This is GCC, so that you're able to compile it. And after compilation, it gives us a executable file called C. So you can run C, and it gives us 2, 1, and 2. So this is the same output as what was provided in this gray box. So now you know that your solution is correct because it's giving you the very same output as what they have provided for us in the tasks for us to solve. So the next one is we have a task that requires us to write a program that performs simple operations. So the question is, a goal is not always meant to be reached. It is often serves simply as something to aim at. So here we are allowed to use the standard libraries, and we can use this following functions or parameters that they have given us, and you can assume that num1 and num2 are integers, so these are variables. I think they are variables, and you can use a toy function to convert them from string input to integers. And the operators that you can use to create these simple operations is addition, subtraction, multiplication, division, and the modulus. And the program is supposed to print the results of the operation followed by a new line. So we need to make sure that the result will be whatever we have found of the operation. So that will be, if we have two values, and in this case we have num1 and num2, which are the integers, that when we, for example, multiply them, it will give us a result, and that is the result we should print to the standard output, and after that it should be followed by a new line. So that is basically what they want us to do. And then we can assume that the result of all operations can be stored as an integer. So we are restricted to an integer in this specific one, so not necessarily a need for it to be a float. And if the number of arguments is wrong, then we should print this word error, and then also followed by a new line, and exit with the status 98. So if the number of arguments is wrong, then that is what you should do. If the operator is none of the above, which is either addition, subtraction, multiplication, division, or modulus, then we should print the word error followed by a new line, and then exit with the status 99. And if the user tries to divide by 0, then we should also print error followed by a new line and exit with 100. So all these are the requirements that we need to satisfy, and we have been provided the allowance to create 4 different files, and we already have the structure for that. This is the structure that we can use, so that is what we will be using. So basically what this will have is calc-h is supposed to contain all the prototypes and data structures that are supposed to be used for the program, and this is an example of how a structure can be. So we will include this, and we have it in our calc.h, which will contain the prototypes. The other thing is we do have a file called 3op functions, and it will contain these prototypes implementations. And what these prototypes will do is the first one will just contain the function for us to add the two integers that we will pass into it. The next one is help us just to subtract. The third is a function for us to multiply. The fourth is a function for us to divide, and the last is the function that returns the remainder of a division or the modulus. So that is what we're supposed to create in 3op functions.c. So this file should contain these prototypes and their bodies, which contains the entire declaration of the function. And the other file that we should have is this file. This is the file that it should have, and it should contain the function that now will select the correct function to perform from the operation depending on what the user wants. So this is also another prototype that we need to include. And lastly, we do have this file 3main.c, and we have been specifically told that it should contain our main function only, nothing else. So that is what we are going to be doing in a few minutes. So here is the very first calc.h. I've already compiled this for us to quickly move through. So we create this file. I've already copied and aggregated all the functions that we are required to have, and they're all contained in calc.h. This is it. So I will paste it here. And that is that. So as you can remember, this is the prototype for us to add. The second one is prototype for us to subtract. This is the prototype for us to multiply. The prototype for us to divide. This is the prototype for us to get the remainder of a division. And this is the prototype for us to select the relevant function and carry out the operation that the user requires. So that's good to go. So the next thing that we need to do is we need to create a file 3op_functions, and it will contain all the functions that all the prototypes and their bodies which have been declared, and it will help us now do whatever it is that we need to do, which is carry out the functions, either add, subtract, divide, multiply, or get the remainder. So that is what we are creating right now. So let me put this here, and then we can look at it one at a time all the way to that point. So let me put it here. So I'll go over one example, and I think I'll go over the multiplication. They're all the same. The only thing that is different is the operation sign, but the body of each and every single function here is the same. So for example, in multiplication, we do have the function called op_mul, which is intuitive to tell us that we are carrying out an operation for multiplication. It takes in two arguments, and both are integers. So it will take the first integer a and the second integer b, and return an integer to us. So what integer should it return? It will return the product of a and b. So it is as simple as that. For subtraction, it's the same thing. It's called op_subtraction, which is intuitive to tell us that we are carrying out an operation to subtract two integers that we do have and return an integer. So it will take a and subtract b from it and return whatever value was obtained from this operation. So that is basically what is happening in this file. So now we can save it and move to the next file, which is now the file that helps us pick the correct operation depending on what the user wants. So here the file is called 3getOperation function. So we copy this that we have over here, and then we paste it there. We start from here, and we're going to explain what is happening, so don't worry. So this is an implementation now of this function called get op function. So what will this operator or function do? It will take a single argument. It will take in a single argument. This is the argument. It will take in a single argument, which is a pointer to a string, and the string is called s, and it will represent an operator that the user wants us to use. So this specific character, it will either be addition character, subtraction, multiplication, division, or the modulus operator. So depending on what function or what operation the user wants, they will provide that specific character that they want us to use, and the function will return a pointer to another function that performs that specific operation that now the user has specified. And the function now will start by declaring an array. This is declaring the array that is named ops, and each and every single structure here, it holds a string representing an operator and the function pointer of the corresponding function that you have. So here we do have the character which represents addition, and the next thing that we do have is we do have the name of the corresponding operation function, which is add, and this is the subtract operator, which now also has its corresponding subtraction operation function. So here we just have both of them, each corresponding to each character or operator character corresponding to its specific function and where we do have it. And the array here, as you can see, it ends with null string or null character in the null function pointer, which will serve as a sentinel value. It will serve as a sentinel value. So the question will be, what is a sentinel value? A sentinel value is just a special value that is used in the context of an algorithm or a function, such that when it is used, it will indicate the presence of a condition to terminate a specific function or operation or process that is being carried out. So if we get null, or if there is no specific character that has been passed by the user, that means it is null. So when it is null, we were told it should return, the process should terminate, and it should return -1 if I'm correct. So that is what a sentinel value is. It will just indicate the presence of a special condition that will grant the termination of a process. So now that we know what a sentinel value is, we can now move to the next bit of what it is doing. So the function then will initialize a variable I to 0, and next it will enter a while loop. So here in the while loop, it will compare the operation that has been provided for each structure in the ops array, the array that was created, with the first character of the string that is being pointed at by s. And s now will contain the specific character that the user has provided. And if the op member of the current structure is equal to null, or the first character of the string pointed to by s is equal to the first character of the op member of the structure, then the loop will exit. It will exit. But once the loop exits, then the function will return the function pointer that is held in f. It will return the function pointer that is being held in the f member of the structure that is now being pointed to by ops and that specific element that is being held. So at the end of the day, what will happen is the function will provide a way, or it will select a function based on the string that represents the specific operation that the user wants to happen. And this will allow the creation of a simple calculator, per se, more or less, for the user now to work out two integer values that they want to get the either addition, subtraction, multiplication, division, or remainder of. So that is basically what they wanted us to do. And now we can save this. And the other thing that they had mentioned for us to do is to create the 3 main.c, and it should only contain the main function. I have already created mine, so let us just have it here real quick and paste it there. And this is the body of this file. This is what it should contain. So now we can save this. Sorry, I think I have the wrong. We can now save it, WQ, and now hopefully we can run our GCC. Let's run it, and each and every single file that is provided here will be used to execute and create the executable file. So here, for example, when we execute the file using this option, so what will happen is calc is the executable file that was created once we compiled all the files into one executable file. And what we want to do now is we want to add 1, which is the first integer value that we have. The operator that we want to use is plus, and the next value that we want to use is 1. So here we simply want to calculate what is 1 plus 1, and it will give us 2. So hopefully that is what it will give us. So now that it has given us 2, I think we can now move to the next and final task, which is the advanced task. And here we have a task for us to write a program that will print the opcode of its own main function, and we can use this provision that they have given us. The output format should have the opcode should be printed in hexadecimal and in lowercase, and each opcode is 2 characters long. It should listing ends with a new line, and we should see example, and we are allowed to use printf and a toy in this task. And if you have to use a toy, you can use it to convert the argument to an integer. And if the number of an argument is not correct, then you should print an error followed by a new line and exit with status 1. And if the number of bytes is negative, it should also print error followed by a new line and exit with a status 2. And you don't have to compile with any flags. So I do have my solution. Let me look at it. The solution should be contained in a file called 100-main opcode. So let's do bi 100 main opcode. This is the file, and this is the solution. Let's go to the end of the solution and explain what is happening here. So let me copy this first so that you're able to view it in Git bash. Paste it there. So here we do have a program that will take in one command line argument, and it will specify the number of bytes of the opcodes to printf for the main function. So in the main function, what it will do is it will print the opcode of itself, which is what we're supposed to do. Argc is the number of arguments. So argc stands for argument count. Argv stands for argument vector. So argc is the number of arguments that have been supplied to the program. Argv is an array of pointers to the argument. So an array is simply vector. So this program will take one command line argument, as I have previously said, which will specify now the number of bytes of the opcodes to print for the main function. And then it will use a pointer to the main function and print out the opcode in hexadecimal format. So at the end of the day, it will declare variables bytes. It will declare variables bytes. So here we've already declared variable bytes and index as integers, and address as a function, So this is declaring address as a function, to an integer function, and this integer function will take in an integer and a pointer of character int, and also the address is also a function pointer to an integer function that takes in an integer and also takes in a pointer to a character array and initialized to a pointer to point, initialized to point, sorry, it will be initialized to point to the main function, and the opcode as an assigned character. So it will check that the program that was called has exactly one argument. So this is where it checks if it has exactly one argument. And if not, it's now supposed to print the error that you are supposed to do and exit with status 1. And then it converts the argument to an integer and assigns it to the bytes variable. And if the bytes value is negative, then it will also print an error and exit with status 2. So that is also happening here, where it is checking for the arguments, where it is converting the arguments to an integer and then assigning it to bytes. And if the bytes are negative, then it prints the error and exits with status 2. So after all this, what it will do next is it will loop through bytes. It will loop bytes number of times, because this is now the for loop. This is the for loop that we are using. So index is initialized at 0, and we are checking that index is less than bytes, and if not, we continue incrementing until we reach to bytes. So what will happen is it will loop bytes number of time, where bytes contains an integer value, and it will print out the ops code. So here it will print out the ops code that is there in hexadecimal format. So it first reads the bytes. It first reads a byte at the memory location that is being pointed to by the address, and the address is here above. And then it assigns it to the opcode variable. So all that is happening here, I believe, in the for loop. Let me highlight it. It is happening here, and it will then print it out using the printf. So it will print it out using the printf function, and it will do this using this %.2x format specifier. So this will ensure that each opcode is printed as a 2-digit hexadecimal number. So this is one of the format specifiers that, if you didn't know, now you know. It will just ensure that each opcode is printed as 2-digit hexadecimal. And if it is not the last opcode to be printed, it will also print a space character as well. So that is happening here. If it is not the very last one, it will print a space character as well. And after that, it will increment the address pointer to point to the next memory location, which will now contain the next opcode. So at the end of it all, it will also print a new line, and if it is successful, it will return 0 to ensure that we know that the program has been successful and everything has been accomplished successfully. So now I believe we can save this and we can run GCC, I believe, if it was provided. Yes, it was provided. So we can do that, and we paste it here and we run it. It will give us an executable file called main, and we want to pass 21 as an argument in the executable file called main, and it will give us this output, this one. It will give us something similar to this, so let us see if it will give us the same. And it has. So at least now we know we are good to go. So it doesn't necessarily need to be exactly the same, but this is the output that we have for this one. And now at least we can close and know that we are happy. I hope you've been able to understand each and every step that we have covered in this task. Make sure you go through the content and you're able to understand each and every single thing. Make sure you watch the quiz video for you to be able to understand the questions that are there, because they will definitely help you in doing the tasks that we have today. And if this video was good, please give it a thumbs up, like it, share it, comment down below. And if there's anything specific that you'd like us to look into, also let us know. We will gladly do that, because we all want to learn and we all want to become better African tech gurus. And that is all for today. And until next time, happy coding.